Hi, hello everyone. In this video, we discuss how to differentiate an exponential function. Right, so first we begin with the derivative of exponential function. So these are kinds of the exponential function. As I said before, is the base is a. So this also base a. So the difference between first and second, the second one we have a coefficient or the function at the power. So for these two, as you can see, the differentiation of this one is first one we copy. Okay, first we copy, right? And then second one learn that base. Okay, so let's say we have 2 power of x. So means that when we differentiate this one, we copy this 2 power of x, and also later we learn with the base that is learn 2, right? So for the second one, if we have a coefficient, and then the coefficient we put at the front. So such as if here we have 2 power of, let's say 3x. So after we copy down, okay, the first one copy down, and then second one learn base, and then the third one we differentiate and we put at the front. That is 3. Okay, so maybe this later on we can rearrange. So we put 3 ln 2, put a bracket, and then 2 power of 3x. So I think it's better for write like this one. Okay, so in general, if we have a something function like this one, so we just means that we differentiate also. Either we put at the front or at the back. Later on, you just have to rearrange. And then if we have natural log, so as you can see, natural log, we just copy and no need to put ln, right? Because if we put ln, so ln base e is actually 1. So that's why we don't put ln. So we just copy the exponent. So if we have coefficient at s, we put coefficient at the front, and also we have a more complicated function, we just differentiate at the power and put at the front also, right? Right. In this example, differentiate the following with respect to x. So the first one, y equals to 5 over x. So the differentiate, since y in terms of x, so we can rewrite as a dy dx. Okay, so dy dx equals to, remember, first one we copy down, and then the second one learn that base. So base 5. So that's the answer for question A. For question B, also y in terms of x, so dy dx. So remember, first thing we copy down, and then second we learn base. So here is base 3, so learn 3. And then also we have to remember, we have to differentiate this one. So differentiate this one. Right. So we know differentiate this one will get 2x minus 3. Right. So we rearrange, we put 2x minus 3. I think we put coefficient ln 3, maybe a coefficient we put at the front. So ln 3, 3 power of x squared minus 2x, and then lastly 2x minus 3, right? And then last one, we have 4 power of 2x cubed minus ln x. We yet to learn ln x, so I just to give you the solution for ln. So as for ln, the differentiate for ln is 1 over x actually. So for this one, so dy dx, because y also in terms of x, so dy dx equals to, remember first we copy, then second we ln base, that is ln 4, and then thirdly we differentiate this one. Okay, so I think this time I don't need to put this like the second example. We straight away differentiate. So straight away differentiate, so we got 3x squared minus ln. Ln is 1 over x, differentiate of ln. Okay. I think we just leave it the answer just like that also can, right? No need to rearrange. Okay, so that's the answer for question C. Right, next in example 12. So differentiate these questions. So the first one, function f is 4ex. So differentiate this one, f prime. So f prime equals to 4, copy exponent, so also exponent. Okay, just like that. Then for question B, the function given is e3x. So f prime, so copy e3x and then differentiate 3. So the answer is 3e3x. Next for question C, e negative 3x squared plus 4x, right? So f prime would be, remember first we copy, and then we have to differentiate this one. So differentiate this one, we got negative 6x plus 4. So we can factorize further, or maybe just leave it like that also can. So if you want to factorize, we put 2 outside. So here 2 minus 3x, and then e negative 3x squared plus 4x. Okay, and then after that we also have question D and E. So for D and E, we'll show the solution on the next slide. Okay, for question D, so this is the question. So as you can see here, we have two terms. So for that, we define this one as EU and this one as a V. So don't forget, you have to find out first U prime and V prime. Okay, write down U prime and V prime because in the exam, they will be marks if you find out first U prime and V prime. So U prime is copy 3 and then 3e to s and then differentiate 2. So 3 times 2 we can simplify, we get 6e to s. And then for V prime, remember we have square outside, so we have to put 2 at the front. And then the power will become power of 1. And then later we have to differentiate inside here. So differentiate x squared plus 1, it is 2x. And then 2x and 2 we can expand or multiply. So we got 4x times x squared plus 1. Right? So that's for U prime and V prime. So as you can see below there, they say we find out U prime and V prime in the formula directly. So as you can see, it's u, v prime, v, and u prime. Okay, next, what happened here? So remember, in differentiation, after you apply the whatever rules, after that you have to simplify. So in order to simplify, usually when we have exponent, we will factorize. Okay, we will factorize, and then as I said before, here we have 4x, x squared plus 1. So here is 6, and also we can also factorize 6, because we can we can divide 2 and then put 2 here, so we can factorize 6e to x. And then also we have x squared plus 1 here and also here. So the lowest one is this one, x squared plus 1. So we can factorize also x squared plus 1. So leaving only, remember, I want to cancel out, we have only 2x, so here 2x only. And then here we have another x squared plus 1, so here x squared plus 1. So this is how we simplify, okay? And then further simplify, here is x squared actually, okay? As you notice here, it's actually x squared plus 2x plus 1. So here also we can further factorize, so it is actually the same factor, okay? That is x plus 1 squared. So in other words, you have to factorize. If we can factorize, okay? So this is the simplest form as our final answer. Next, for question E. So for question E, we have a quotient rule. So here is u and below is v. So remember, as question D, you have to find out first u prime and v prime. So for u prime, I think same as question D. So copy and then you have to differentiate to x, that is 2. So we have 6e to x. And then for v prime, so differentiate x squared, we get 2x. Okay, so we apply the quotient rule. So remember, for quotient rule, we have vu prime minus uv prime over v squared. So vu prime, this is not the answer because here they not differentiate yet. So they are after differentiate is actually this one. Okay, same as what we get. And then minus vu prime. So vu prime, okay, also same that we got, that is 2x. And then how we simplify after we apply the formula? So let's see, right? As you can see here, we have exponent, okay? Exponent 6e to s. Remember the previously 6 also, right? Because here, even though it is only 3, but here we have 2. So 3 times 2 also 6. So we can factorize 6e to s. So after we factorize 6e to s, we got x squared minus 1 and also only x, right? Because 2 already together with 3 to form 6. So we got x squared minus x from here and minus 1. Can we factorize this one like question D? Check with your calculator. If you can factorize, then factorize. If not, that will be your final answer in quadratic. Okay. So next, example 13. So given y equals to x e power of negative x. So find dy dx and d2y. So remember, this is the second derivative, d2. So this is the first derivative, the normal differentiate. And then show that the second derivative plus 2 times first derivative plus y equals to 0. So first we have to find out. first and second derivative. So this is the function x e power of negative x. So remember, this is product rule. So this is u, this is v. So u prime 1, v prime is e negative x times negative 1, okay? Because we copy and then differentiate negative x. So we got negative e negative x. So here the v prime, so u v prime plus v u prime. So after we apply the product rule, so notice that we have exponent, so we factorize exponent. So here we have negative, so negative x we put at the back, and then here positive we put at the front. So 1 e negative x, that, and then 1 minus x. Then after that we have to again differentiate to get the second derivative. So again we find out u prime and v prime over here. So u prime also same. Here e negative x will become u. So remember the previous one. For e negative x we got negative e negative x. And then for v prime it is negative 1. So apply u v prime v u prime. So after we apply, and then remember, like the first derivative, we have exponent, so we factorize exponent. So here we have negative. So negative means that after we factorize, here is negative 1, and negative means the sign here will change. So now it will become minus 1 and plus x. So that's why at the end will be x, and also negative 1 means that minus 2, right? So that's the second derivative. And then the next question, you have to show the equation given it is equals to 0. So in the equation you have to substitute y first derivative and also the second derivative. So substitute. Then after we substitute, show that it will cancel out each other. So e negative x. Actually this one not cancel out, this is positive, so 2. So cancel out this with this one, negative 2 x, okay? And then here the same factor we can cancel out. So we can show that it is actually equals to 0. Right, so that's all for our video regarding differentiation of exponential function. So the next video we discuss how to differentiate a log function. So stay tuned for this video. Thank you.